Hey everyone, my name is Izzy, Israel Wilkins, or Izzy is, whatever you want to call me. And in this video, I'm going to show you how I made Super Mario Bros. 3 in Python using a development environment called processing. If you don't know what processing is, it is a programming language slash development environment that helps you draw things on a window. That's essentially all it is. And I made this for a final art project of mine for a college class that basically whole premise is using code instead of hand making it with your hand. And I had a lot of fun. So let me actually show you the project. Oh, 1 second. I still have the reference image. Let me just comment that out. All right, the sound isn't working, unsurprisingly, but essentially, if Mario is supposed to be jumping and making a sound like the ding, like he's supposed to be doing that, but for some reason, processing has a hard time even with the library because processing meant for Java and not Python. Even it does support Python, but it's mainly used for Java. But anyways, as you can see, this is Super Mario Bros. 3, or at least kind of Super Mario Bros. 3. There's some assets that are missing, like the white border on the UI and the piranha. There's supposed to be a piranha plane here, but I didn't have enough time to make them. But in any case, yeah, this is Super Mario Bros. 3. Now, I'm actually going to show you how I made it. So let's first start off with the really general things that are on the screen right now. So first, there's a couple images on the screen. Not everything you see is an image, but some of these are images. So for example, the UI down here are images, not the background itself, but the UI. So the star sprite, the mushroom sprite, this world 1 area, I'm not sure exactly what they call it, but this little areas right here, this is all pictures. The clouds are also a picture instead of a handmade sprite which I will talk about later. These are also pictures, but everything else you see on the screen is made by code. So let's start off with with the clouds here. So the clouds are, since they're just images, there's not really a lot I have to do. To make sure you can understand more easily, processing uses a grid system where this right here is the y coordinate, the top from the bottom is the y coordinate, and left to right is the x coordinate. So let's say, I don't know if you can see my cursor, but let's say this question block right here. This question block is probably at actually, well, let's see. This question block is at 610. So this is at x 610, and it's based off the corner here. So this is x 610 and y 230. So 610 and then 230, and then that's how the block is placed right here. What that has to do with the clouds is that I basically set a random y coordinate from 15 to 90. So it could be either, the clouds you can tell from the console, these logs right here. You can see down here that it's randomly going from y coordinate 3783 to 5535 to 8973, and these are just the different clouds. Right, cloud A is somewhere here, and cloud B is somewhere here. I guess this is cloud A, and then that's cloud B that just passed. But that's all it is. It's moving 1 x unit to the right every frame, and in this case, a frame here is 0.16 seconds because this is a 60 frame window, 60 FPS window that you're seeing right here. So yeah, cloud's pretty nice. There are just images after all, and it's nothing too complicated for many people. At least most programmers, I should probably say. This next thing is a platform. So these platforms that you see Mario standing on, I think the official game called them semi-solid blocks, but I just call them platforms because that's a lot easier to name for a function. So this is the blue block that Mario is standing on, And what these first three values mean, if we can actually, let's just go to the function. Let's go to the function. These first three values are just the color of the block. So this is the red, the first one's the red value, the second is the green value, and the third is the blue value. And then the fourth and fifth parameter, as they call it in the programming world, the fourth and fifth parameter are the x and y coordinate we talked about earlier, like just like how we place with the blocks. So this is probably, I don't know, like 210 in the x coordinate, and then like 240 in the y coordinate, and then it draws like a, and then we give it size in x. So this is probably, it's basically, just think of it as another point, but drawing like this. So this is our x and y coordinate right here, and then this is our size coordinate, our other point, and all we're doing is just moving this point from, let's say, 50 extra from x here, and then 50 extra from y. That's all we're doing. And there's also the screws. The screws are in a helper function, which is just a function that helps another function. That's all it really is. Now, function is just a line of code. If you just in case you don't know, a function is just a block of code that you can reuse a lot. And since we have multiple platforms, I can just say platform block and then just put in those parameters like the color and the x and y coordinate and the size. Some pretty nice stuff. And it'll help if you don't know programming. Helps a lot, and it's in pretty much any program you see. So other than the blocks, let's talk about the pipe. The pipe is actually a pretty fun part of the project. It's actually two things. There is the pipe itself, which is this area, and a little area below this, what I call the pipe head. So pipe was pretty fun to make because in the original game, it has these highlights on the left and then these shadows on the right. And all they were was just some rectangles. So I just made the rectangles. I made the little shadow here. The stroke came out naturally because processing automatically gives all objects a 1 pixel stroke. This stroke size is actually 3 pixels, and it looks close enough to the game, which if you look at Mario, it kind of basically looks like the stroke size, probably the pixel size of the game. So yeah, is that since it's 2 parts, if I were to remove the pipette here, close our program, and then rerun it, you can see that there is no longer a pipette because I took it out. I took out the pipette, but I can just put it back real quick, and it should be back. Look at that. All right. The next thing I guess we should talk about is Mario. So, or actually, the question mark blocks. I completely ignored that. The question mark blocks, they were a bit of a challenge, I should say, because animating doesn't really come naturally with processing. So I had to make animation, or at least I didn't use, because the final project didn't allow any outside libraries other than sound. I had to pretty much make a way for the program to animate. And all I did was, first I had to make the question mark block. That's pretty easy. It's pretty much the same process how we made the platform blocks, but without the X and the size, because I wanted these to be a set size. I didn't want them to be, I don't want the user, or I guess in this case, me, to expand the question mark block size any more than 45, because, or well, just didn't want to, just we want a consistent size, because otherwise, something tragic might happen. Like it may not work the way it should. So they have it's pretty much a set size. Now the screws, they're pretty similar. All they're just the same reason why this happens. It's just coordinating the X, Y of the shapes, and just doing some math to make sure that they're actually in the position they are. The question mark itself was a little hard because I had to hand make it. And by hand make it, I mean literally hand make it. So if you can see here, right here is the first frame of the question mark. So question mark pause position. This is the first frame. Programmers like doing things in 0 first and not 1. So the first is a 0 here. Just for as a note. 0 is the the regular question mark position, which is the regular question mark. So you ever play Super Mario Bros. 3, which you probably did when you click on this video. That's the question mark. And then for the animation to make sure that the question mark doesn't overflow to the other question mark blocks, I had to add a clip area. So all that does is mix clips, or really it's kind of like a box. So it makes sure the question mark doesn't overflow to this next box. So you see this here, clip. If I were to remove it, you're gonna notice that the question mark block is gonna overflow, especially in the, I think the second frame here. And because I didn't want, that's pretty ugly, so I added a little clip blocks, and I got that working so it doesn't overflow. I think it actually still overflows to the stroke. It's like little black pixels, but many people didn't notice it. I actually don't think anyone noticed it when I presented it to my class. So, not really of an issue. But I think that's all there is to talk about for that. Well, yeah, there's the ground. Just really quickly, just to get this over with. The ground isn't really that interesting. All it is just this is one big rectangle. This is also a rectangle, and then these are just a bunch of lines. You go to the function here, you can notice that all it is just a bunch of lines. These lines here, these are really the hardest part, because it just had to make some type of coordinate system so that they actually constantly generate, because it's just the same line. This isn't this isn't a crazy amount of programming to get these lines to work. I just put it in a loop. I just made 100 of them, so that's what this is. It's just in a loop, and I made 100 of them, and right here is obviously you can't see 100 lines because they're going outside of the canvas in the window. There's about probably I'll say 20 lines here, and I just said 100 because just in case. It doesn't really matter. It's not like this affects any performance issues or anything. So the ground was pretty boring. But the most interesting part, I would probably say, is Mario. Now, again, there's supposed to be a sound playing. As you can see, there's supposed to be a sound playing when I click the mouse button. But of course, it's not working because, like I said earlier, I think I said earlier that processing has a hard time with sound. The Mario code is a little complicated. Probably not that. It's not really that complicated, but the most complicated in the project is what I would say. So first, I had to make sure that Mario has a limit, because first I had to make Mario jump. In order to make Mario jump, forgetting about the jump sprite for a second, I had to decrease the Y value. In this case, since the Y is actually in the corner and not like in the center of the screen, so I have to decrease the Y value. So instead of something intuitive like Mario's from 210 to 255, that's that height. It's actually 255 to 210. A little complicated, a little unintuitive for some people, but I still got it through. And then there's also him having to come back. Well, first, for him to come back, there needs to be a set height, since unfortunately, there's no physics in this. This isn't like a game engine where it's integrated physics. I essentially had to make a height limit so he couldn't jump forever, because that would be a mess. And then I also had to set a fall speed, so Mario falls gracefully and not just that. This would be stupid. Why? And I feel like Mario shouldn't be doing that. And then there's also making the sprite. That's it for him jumping part. The hardest part was not actually that. It was actually just making him was actually the hardest part, because again, he is not an image. He is a handmade sprite that I had to make from a make-believe coordinate system that I made for myself. It started with 5-1. Usually most coordinate systems are at 0-0, but I decided, because the top of him is at the very first pixel that you see when you go from top to bottom is this black pixel, and it's at coordinate x5 and y1. You can see if I were to remove this first pixel, this first line, rerun the code, you can see Mario's black outline is shaved off. He's gone. His black outline is gone, and that's just because that is how I made it. So I basically made it kind of like scan line. Well, initially it was kind of like scan lines. Sometimes I would make if it was like a rectangle like Mario's nose here, I would just make it like a rectangle instead of like a square. But honestly, this isn't really that interesting to talk about because it's just me placing a bunch, saying the same thing over and over and over again. Again, I kind of regret making him like this because was it cool? Is it cool? I kind of a show off, I guess. Yeah, but I personally probably don't think it's worth it. It is authentic to the program, even though I didn't use images. It is authentic. I did really want to make Mario in the program itself and not just take a sprite of him. But it just actually took like the most hours. This probably took me like what 5, 6 hours because it's just so tedious. I had to make both his idle and jump sprite. This is probably the reason why I actually didn't integrate the running part. Because A, I need collision. B, I need some type of physics so he doesn't just jump all over the place. There's a lot of things to consider, especially to make him move. Especially something as seemingly simple just to make him move requires a lot of behind the scenes work that many people won't care about or see. And honestly, that's probably the reason why I made this video, just so people can see the behind the scenes when it comes to making a project like this. If you have any questions, you can go to the comments. And this, just in case for anyone who's curious, this has around 600 lines of code. Here are all the variables. Here's all that. You can tell this is the window size, 668 by 720. And yeah, thank you for watching. Hope you guys enjoyed my little art project that I made. I think it was 13 hours. Yeah, 11 to 13 hours. Took a couple of days during finals week 2. It actually kind of like an unwind to make this while finals were going. But thank you guys for watching, and I will see you guys later.